Hello, my name is Caden Dooner. I'm a 17-year-old. I'm a senior at William T. Dwyer High School. I also work with Blue Cube Aerospace, and I'm a part of the Wolverine and Wolfpack CubeSat development teams. With those teams, we've recently been working on our new project called the Mars Lunar Rover. That's going to specifically look at lunar dust mitigation on spacecraft in low gravity freefall environments. A little bit about ourselves. The Wolverine CubeSat development team was founded in 2015, and since then we've been doing a lot of projects involving high altitude balloon launches, and we've even been selected for two proposals through NASA's CubeSat launch initiative. One of those being our WISeSat, which launched in 2018, and our CapSat, which we are currently developing right now. We've also been engaging students in PBL learning, problem-based learning, and as I said, we're working on our new project, our Mars Lunar Rover, which is a small one-use sized CubeSat rover that will be testing whether we can mitigate lunar dust using specific properties. For this experiment, we'll be using electric and magnetic fields to see if we can mitigate that lunar dust buildup. Lunar dust has been a problem for a while now, probably dating back to the Apollo 17 era when we first landed on the moon. It was logged right in the mission objectives. It was logged in the mission that Apollo 17 had difficulty operating due to that dust. Since that dust has a tendency to stick to everything, it even clogs up some vehicles, and we can't have that. The dust is also believed to have toxic properties, so if inhaled, that could cause a lot of problems for the dust. However, something very important about this dust and for the experiment is that once the sunlight strikes that dust during the day, of course, it becomes positively charged by knocking off electrons, and that creates the positive charge. For our rover, we want our equipment to be positively charged. Since we're going to be going during the day and the dust will be positively charged, we want to repel that dust. For our experiment, we created a lunar dust box made out of some Lexan sheets. This was simply just to hold the dust and everything in it, just so that we wouldn't make a mess, and so that we could simulate a space-like environment by pulling the vacuum on that box as well. We used rubber gaskets and adhesive sealant to seal it up, just to make sure that there were no air cracks and so no air could escape. We also used a gate valve so that when we turned on the vacuum, we could shut it off quickly and better simulate what it's like to be in a space-like environment. Since we don't have a prototype of our rover yet, we used some pieces that are going to be on our rover, which we used a 5 centimeter by 5 centimeter solar panel in place of it. And our simulated regolith we got from UCF's Exolith Lab, the LHS-1. For our magnetic field, we used a 50-pound magnet or 10,000 Gauss for our magnetic field. As we know, the larger the magnet, the stronger the magnetic field. We want to repel as much dust as possible, so we tried to get the largest magnet we could find. For the electric field, we also used indium tin oxide plates. We used two of these and ran a current through one, a positive current through one, and a negative through the other using our DC power supply. This created the electric field right in the middle. And of course, we used a vacuum pump. That's just to simulate the space-like environment in the dust and have no air. So of course, when we talk about electric and magnetic fields, we're going to be talking about the laws of electrostatics. The laws of electrostatics, of course, we all know, like charges repel, opposite charges attract. Since we want the dust to repel from our vehicle, we want that our equipment to be positively charged, since, of course, lunar dust is positively charged when the sunlight strikes it. We're also going to be using the vacuum theory a lot. Since our container is sealed, the pressure will be increasing and expanding in volume. We're also going to be using a continuum flow for our experiment. We did the experiment. We first tested the ITO plates just to make sure there was no drop off of voltage when we ran it through, and just to make sure that there wasn't any problems with it and it wouldn't alter the experiment at all. We did find there was a 2% drop off of voltage through those ITO plates when we ran through. That means that they didn't really affect anything in the experiment. There was a very low percent drop off, so all the current ran through those ITO plates. Using the equations from the last slide, we calculated the magnetic field strength by hand, and that came out to 7.11 times 10 to the 5th Tesla. We also did that for the electric field, and we got 3,000 volts per meter. which we plugged into another equation from above, and we found the point of charge. When we actually did the experiment with all this information, we found that the electric and magnetic field did not have any effect on the dust. However, we would later figure out that that dust needed to be ionized and tribocharged since it wasn't already tribocharged. We did another experiment using this method. However, we didn't show any results. We tried to tribocharge it by pouring the dust through various plastic blocks, in this case Lego blocks, for a certain amount of time, and we didn't have any show in ionizing the dust. However, more tests will be done in the near future. As I said, we're doing more tests as we speak, actually. We're going to be repeating the experiment using proper methods, including a Van de Graaff generator to try and ionize that dust, and using that tribo charging method once again. We also need to find a way to magnetize the dust, since not all the dust particles in that LHS1 are magnetized. So we're going to have to find a way to use that, since real lunar regolith is magnetically charged. During this experiment, we did have a bit of difficulties. Like I said, with the dust, it wasn't ionized fully, and there wasn't a lot of magnetic properties to it. So we just want to find a better way to ionize it and to magnetize it. Constructing the dust box was also a bit difficult, only because it was kind of a makeshift way, but it served its purpose. We just want to make sure that there's no air cracks or anywhere that the air can escape next time we build this. Calculating the electric and magnetic field. We did this by hand. There's a lot more room for error when we do that, so we want to try to find another way to calculate it using something like an Arduino code, which we tried earlier, but we couldn't exactly figure out. So doing it by hand was our best alternative, but we definitely want to find another way to do that so we can eliminate the room for error. As for Mars, we are set for construction in 2021. We hope to get our first prototype out very soon as well. We have found all materials for our 1U-sized rover, and we are ready to purchase those materials as well. As for whether using electric and magnetic fields to repel that dust, we have discussed it, and we think that using both, if we can find a way, would be very beneficial for our rover. Magnetic fields are better used when the particles are actually moving or when the magnetic field is moving itself, and electric fields are better when the particle is stationary. So if we can find a way to use both, that would probably be beneficial for our rover and repel the most dust. We still want to complete more tests on this rover, and we are going to purchase all materials in the near future, and of course build, test, design, and launch very soon. We hope to be back soon with our finalized product, our finalized rover, and more information on this experiment. If you have any questions, concerns, or if you have any ideas, just let us know. Anything helps. And as for our rover, we hope to be back next time with our finalized product. I want to thank you all for your time, and have a great day.